Hello! In this video, we will be defining the concept of circularity, taking a look at its origin and key components, and considering how circularity translates to our scale of focus, that of the region. You will find out that although circularity can be understood as a scale-free concept, active strategies to achieve it, whether from a governance or a design perspective, do require a scale of focus. The setup of this introductory video is as follows. We will first define circularity and the concept of circular economy, linking it back to sustainable development. Next, we will focus on the necessary systemic perspective and inclusion of social equity. In the final part, we will explain the concept of value chains and how to translate them to general circular strategies, and explain their multiscalarity and the importance of the regional scale, also showing how scales interrelate by using an example from the food sector. But let us first of all start by placing it in its context. As you already will know, sustainable development requires a systemic approach. Our society is dependent on all kinds of resources, such as materials, water and energy, and therefore is highly dependent on the infrastructures which carry them. The complexity of these networks is ever increasing, and their vulnerability to change is increasing in parallel. Drivers of change include resource depletion, as well as climatic, demographic, political and technological factors. There's a growing consensus that the world may be entering a period of scarcity, so it is more critical than ever to adopt a sustainable approach to development. In this complex setting of so many drivers of change, people, institutions, policies and systems are crucial starting points. An important step forward occurred in 2015 when the world embraced the 17 Sustainable Development Goals, or SDGs, which clarified that political will and community acceptance are essential for sustainable development. Though a component of other SDGs as well, SDG 12 in particular stresses the need for greater circularity, specified as responsible consumption and production. As you can see here in the 5-year evaluation of the SDGs, we are actually lagging behind with regard to SDG 12 and several others. Now, by taking a closer look at regions, and in particular city regions, we can distinguish many resource and waste flows, as shown here, for instance, in the waste flow diagram of the larger Amsterdam metropolitan area. One could actually use the analogy of the metabolism, a framework for modeling complex territorial systems, material and energy flows, as if the territory were an ecosystem. It helps us to study the dynamics of a territory in relation to scarcity, carrying capacity, and conservation of mass and energy. Now, as we have seen in the example of the Amsterdam metropolitan area shown before, our actual economy can be framed largely as linear. The prevalence of reuse within the economic models is increasing, but right now there is a little that can truthfully be considered circular. So what distinguishes a linear economy from a circular one? A linear economy converts natural resources into waste via production. Within this process, natural capital is removed from the environment, and by pollution or waste, the value of the natural resource is reduced. In a circular economy, however, there will be no loss of value, and the net effect on the environment will be zero or even positive. This is also called a regenerative overall effect. In 2008, the Ellen MacArthur Foundation introduced the so-called butterfly scheme to explain a circular economy, with biological loops related to renewable resources and technical loops related to finite resources. The former achieves circularity through cascading, the latter through the so-called R-ladder approach. Concepts integral to the loops include regenerating or substituting materials, but also virtualizing material change and/or restoring all. This, of course, with the aim to minimize systemic leakage and negative externalities. Reality, unfortunately, teaches us that there's still landfill and waste that is incinerated, the so-called low-value recovery, in this case of energy. Actually, Overall, only about 9% of all global material resources at the moment are recycled annually. This is also referred at as the circularity gap. In the previous example of the Amsterdam metropolitan area, the largest share of material resources and its use is associated with housing, infrastructure, followed by nutrition and mobility. This brings us to the need for systemic thinking and the inclusion of social equity. For instance, look here at these graphs. The first graph to the left shows environmental load related to energy resources, and the second includes materials in the scope. And a more nuanced image arises. Where we all thought that the desired move from left to right, in the left image, tells a clear story, once adding special metals, in the right, the overall assessment could be different. And this is why circularity requires a systemic thinking approach. And this means also the importance of including a social equity perspective, such as elaborated, for instance, in the concept of donut economics. If you apply this further to the field of spatial planning and development, it could be summarized as suggested by Metabolic as the 7 pillars of circularity. Materials in the economy are cycled at continuous high value, water is extracted at a sustainable rate and resource recovery is maximized, biodiversity is structurally supported and enhanced, human society and culture are preserved, human activities generate value in measures beyond just financial, and the health and well-being of humans and other species is structurally supported. And all of this, of course, from the perspective of equity, resilience, and transparency. This brings us at the final part of this video, related to circular strategies, value change, and how the notion of multiscalarity and how the regional scale is crucial. Remember the 2 value chains in the circular economy butterfly scheme of the Ellen MacArthur Foundation? It comes down to either retaining value in the technical material chain, in the case of non-renewable resources, or, in the case of renewable resources, retaining value in the biological material chain. However, the ultimate goal should always be to try replacing non-renewable with renewable resources, as shown in this overview of both value chains. The stepped approach to be applied to achieve an optimized cascading of these values is also known as the R ladder, with 10 circularity strategies from linear to circular. These 10 circularity strategies can be clustered into 3 groups, namely narrowing loops, which decrease resource use, slowing loops, which extend product life, and closing loops, which recycle materials. And eventually can be translated into 10 design strategies, which focus on resource reduction for narrowing loops, durability and standardization for slowing loops, and recycling in closing loops, as seen in this picture. Which brings us at the importance of a regional approach within a multiscalar perspective. As we have seen, circular strategies require a systemic perspective. This is made even more critical by the fact that an increase of scale often results in increased complexity and interdisciplinarity. And it leads to solutions that cannot be found, considered, or assessed at a micro, meso, or macro scale in isolation. They are all interconnected. To explain this, I use here the example related to urbanization and agriculture. We can look at the effects of urbanization and the resources required to feed urbanized societies, which altogether result in cascading effects of land encroachment. In the end, this reaches the limits of our global terrestrial ecosystems, as defined by our planetary boundaries. And this is also known as the unfair teleconnections impact on the Earth system, which makes it impossible to realize a circular society with regards to food. To overcome this, it would be necessary to respond with global advisory planning policies which align with regional planning, preserve urban croplands, and maintain and restore soil quality through protecting and facilitating movements in the regional, urban and peri-urban agriculture, and with robust common property rights. These same regional policies could then further enable building circular economies and food security, and building it locally. In such an approach, within the example given, a multitude of recovery pathways, as shown here, achieve circularity. Acting on such leverage points to curb urban encroachment may simultaneously balance import dependencies and decrease national demands that drive unfair and environmentally destructive teleconnections. It highlights how crucial regional policies are in the aim to achieve an overall sustainable circularity, which can also support livability and equity, moving beyond that of just financial values.